What's up? Precalc. I'm just pretty much going to do this video just to see if how long it's going to take, and I'm usually going to record videos during class because I don't like to do extra work, but I have extra time to do this, so I'm going to do it. Get my mouse connected. And then we'll get going. All right, so getting right after it, reviewing just like functions. What is a function? What are we going to do with this function? What kind of functions are we reviewing? A function's like a machine. You know, it's just like something where you take a number, you put it into the machine. Okay, here's my machine with buttons and stuff. And then that machine outputs a number. It could be the same number, it could be a different number. The functions we use in math class are denoted by a letter. So this is the function f. So it's like the machine f. And this machine likes to use x's. Okay, so this 2 we'll call an x. This x gets plugged into the function, and boom, the function is going to output some number that will determine based on what the function is. Okay. Now, this output we typically call a y, but we'll talk more about output. So like here, this function says you plug in an x, take 4, multiply it by that x, and then add 3 to it. This is the function g. G uses x's as well. You take your x value, like that 2, you plug it in to g, and you'll square that x value and then subtract 3. Okay, so that's the idea. This is the function h, and h is using x's. What are we doing here? We are taking that value and we're subtracting it from 2. We were then multiplying that by 3, and then we'll take it forward and subtract 3. Okay, so let's like kind of see what happens when we plug in these values. Like, what if I plug in -2 into my functions? What if I plug in -3 into my function g? What if I plug in 5? So we will take -2, and -2 is going to replace x. Okay, instead of using x, I'm going to use -2. Now, if there was multiple x's in f, I would place -2 into multiple x's. So I got 3 plus 4. Instead of using x, I'm going to use -2. And then what we find is that this can be simplified. I'm going to keep the left side here, like f using -2 becomes -8. -8 plus 3 is -5. And this is the value that comes out of my box. We call this typically like a y value, or a function value, or an output value. Okay, so let's do the same thing with g. G, using -3 instead of using x. Wherever I see x, I'm going to replace it with -3. It's helpful if you use parentheses just so you know that you're taking the entire value of -3. -3 squared is 9. 9 minus 3 is 6. So we have that when -3 is used, the machine will output 6. We have our x, our input. We have our y, our output. All right, and you guys probably could do h of 5. See if we get the right value. Apologize for my penmanship. Some things that I like to do. I like to distribute negatives. I don't like to subtract numbers when I don't have to. I don't like to worry about subtracting negative numbers when I don't have to. I'm just going to remember that negatives times negatives are positives. Boom. Okay. Now, we could also kind of go the other way and say, hey, you got a machine, here's your machine, and your machine outputted something like -2. Well, what got put into the machine to get that output -2? Okay, this is where we will find our x value. We're going to find the x based on what a lot of us have considered a y. So we will take the function, and f of x is equal to 3 plus 4x, and 3 plus 4x replaces f of x. We keep the equal sign, we keep the -2. And now we can kind of reveal the value of x, discover the value of x when plugged into this function that outputs this value of 2 by just kind of undo what's being done or solving the equation that you guys are used to. So like, what is being done to x? We're multiplying by 4 and then add 3. How do you undo undo those things? Well, we kind of reverse what's being done. We can remove the 3, which is the last thing that's being done, and then we will get rid of the 4, which is the first thing that's being done. So getting us x is equal to -5/4. We're going to leave it like that unless we have a calculator. We don't want decimal answers. We don't want improper fractions. Like, that's fine. So this tells me that if f uses -5/4, we would get the y of -2. Okay? And let's see. G of x equals 6. X squared minus 3 equals 6. What is being done to x? X is being squared by a value, then we're going to subtract 3. How can we reveal the value of x? We will undo what's being done. To undo a square, we will use a 1/2 power or a square root. A square root is just a 1/2 power. I like to use these powers just so it helps us with other fractional powers, and I get x could be a positive or -3. Why do I know it's a positive -3? Well, it's because if we're solving an equation, we're using a square root, the value could be both positive or negative, because +3 squared is 9 and -3 squared is 9. Okay, so that means we have both g of -3 would give us an output of 6, and g of +3 would give us an output of 6. And now we have h of x is equal to 5, 4 minus 3, 2 minus x. Undo what's being done. You know, if you want to, you could start by subtracting the 4. Okay, cool. If you want to, you could divide by -3. Or you could consider this to be like an amount that could be distributed. I like to call distribution like emptying the bags. I have -3 bags of 2 minus x. If you have -3 bags of that, like empty them, what do you have? I got -6 plus 3x. I can add 6. Get 7, divide by 3, get 7/3. So h using 7/3 gives us 5. Okay? Now, what is important about this is that what we have are these connected values, like -2 connects to -5. -3 connects to 6 for g. 5 connects to 13. We can list these connections as pairs. -5/4 connects to -2. If we input -3, we get 6. +3, 6. Which is why what we could do is we can list function values as pairs, 2D pairs, x comma y. Now, if we want to visually see these 2D pairs, we can break out a two-dimensional axis, an x-axis and a y-axis, where we can see if you say are looking at f, f has the connection of an input of -2 and output -5. This would be a visualization of f having this point. Now, we could look at all of the points that f has and could create what ends up being a line. So if I plugged in 0, I'd get 3. If I plugged in -4/3, I'd get that. And we would see that all of the connecting, all of the xy points for f would create this kind of picture. And this is where graphs come from. It's a demonstration and it's a list of all of our possible, inputs that are connected to an output. And what we find is that we have these characteristics. An x-intercept. An x-intercept is when we cross the x-axis, or when our function outputs 0, or we have this idea of the location of the x that we're trying to find when the output of the y is 0. The y-intercept is the location on the graph or on the function where when I input 0, what is the y value? Okay, so whenever you're asked to find an x-intercept or a y-intercept, you just got to maybe not necessarily memorize, but think about the picture of a two-dimensional axis. X-intercept, when we cross the x-axis, that's going to be something where we have some input when the y is 0. The y-intercept, when we're crossing y-axis, is what is our output when our input is 0. Okay. That's it. The rest of the lesson goes into specific types of functions that we need to review. So we will spend the rest of the class reviewing those types of functions. And then we have a couple extra problems that are kind of contextualized, where we might be doing some other stuff besides just, hey, find this value, find the x-intercept, find the y-intercept. So here are the ones that we need to be able to do. First, we got to be prepared for a linear function. It may or may not have fractions. We can understand that it is possible to distribute this and simplify this if you wanted to, but it's also possible to leave it undistributed. We might need to remember how to multiply fractions together. We can multiply straight across, or if we look to simplify, because you can, you can divide the top and bottom by 3. When you divide the top and bottom by 3, this 3 goes to 1, this 6 goes to 2, and you just get +4. Or you can go, this is 12 over 3. We will not be able to use calculators a lot in this class. If we want to practice, with a calculator at home, that's fine, but be prepared to use fractions and be comfortable with adding and subtracting fractions, needing common denominators, multiplying straight across, et cetera, et cetera. So anyways, it's up to you whether you want to, plug in as you see it like this, or use the distributed form and plug in 15 here. You should get the same answer regardless. Either it's -2/3 times, let's work inside the parentheses, 9. -2 times 9 divided by 3 is 18. 18 divided by 3 is 6, so that's -6. Here, 15 divided by 3 is 5. 5 times -2 is 10. -10 plus 4 is -6, so boom. You get this j of 15 equals -6, xy point on the graph of j, or just like a connected pair. Next question is, when does j of x equal 15? It's up to you. Again, you could distribute, or if you want to undo what's being done to x, like you could get rid of this negative 2/3. Now, negative 2/3 is being multiplied. You could divide by negative 2/3. What I like to do is multiply by the reciprocal. Gets rid of that, leaves just an x minus 6 here. 15 times 3 divided by negative 2 is 45 over negative 2. And now I have to add 6. 6 is the same as 12 halves. You need to be comfortable with adding and subtracting numbers. So 45, 35, 33. Cool. X-intercept, when the function outputs a value of 0. Y-intercept, when you plug in 0. I'm going to distribute. I will undo what's being done, subtracting the 4. You know, it's actually easier, watch. It's easier doing it the other way. Let's get rid of the negative 2/3. Maybe divide by negative 2/3 or multiply by 3 halves. Look at that. Add 6. Easy. Easy to do that without distributing. I think maybe in class today, I'm going to make sure I review some fractions. Adding fractions, multiplying fractions. So there. Isolated x to powers. We can go ahead and do this one. Just make sure when you're plugging in, you're understanding that everything else stays the same. This would be a good one for the class to do. See if they get the same value. And here we go. One thing we have to remember is how to rationalize. So review of rationalizing. What we want to do is find the perfect square that goes into our value. Why do we want to find the perfect squares? Because perfect squares can be square rooted. Like 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3. We can rewrite 12 as 4 times 3. So I could actually use root 12 as rewritten as root 4 times 3. And then the square root of 4 times the square root of 3 using a exponent property can be done. And we realize that this is 2 root 3. Whenever we understand that an unknown squared gives us a positive, the unknown could have been positive or negative. Whenever we use a square root to solve an equation, we need a plus or minus. Any even power, plus or minus. Now we have this one over here, which is important because cubing is multiplying by itself 3 times. If I take negative 2 times negative 2 times negative 2, I get negative 8. Oh, and look at that. Pretty much give you the answer to the next question. We know the answer is negative 2. But what do we realize? There's no plus or minus. Like a negative value cubed is a negative, a positive value cubed is a positive. I think a lot of this class that we're about to adventure into is like me seeing where people stand. So I'll walk around and have you guys collaborate and check your work. and we'll get the same answers, you know, in the end, but I'm not going to really teach it to you. I'm more going to see like, yo, how well do you remember this stuff? Okay. X-intercepts when the output y is 0. Y-intercepts when the input is 0. So 8 minus x squared, when does that output 0? When does x squared equal 8? That's when x equals plus or minus root 8. Root 8 is root 4 root 2, which is 2 root 2. Add 5 divided by 2. Instead of using a cube root, you could use a 1/3 power. I don't know what the cube root of 5/2 is, so we're just going to leave that. What is important is that we don't worry about the plus or minus. We could list our answer off as that. We need to be comfortable with it being that. Y-intercepts when x is 0. M of 0 is 8. N of 0 is negative 5. Okay, negative exponents. Easiest way to remember negative exponents is to use numbers. Also helps you with 0 exponents. Like the question is, what's 3 to the negative second? Well, I know 3 squared is 9. I know 3 to the first is 3. How do I get from 9 to 3? I divide by 3. So if I kept going and divided by 3, I'd get 1. I'd get 1/3. And if I divide 1/3 by 3, it's the same as multiplying by a third. I get 1/9. Well, 1/9 is the same as 1 over 3 squared, which is telling us that negative exponents are the same as a reciprocal positive exponent. It's like we're dividing this many times versus multiplying. You're dividing 1 by 3 twice instead of multiplying 1 by 3 twice. So probably right from the start, I'm writing this as 18 over x squared. And we can then accomplish these two values. Negative 3 squared is 9. 18 divided by 9 is 2. 18 over x squared equals 24. I'm going to go ahead and multiply by x squared. Divide by 24. Simplify this. 6 can be divided in the top and bottom. It's 3/4. Square root the top and the bottom. Or it's a 1/2 power. I get the square root of 3 over the square root of 4, which is root 3 over 2. We'll see this value more often in this class. Plus or minus, because we started with an even power in our squaring. You will see rational exponents. Doesn't have to be a square or a cube. It could be this fractional exponent. It's important to be able to evaluate values to, so I'll probably do a quick review before we get going. So a quick review. Say x to the 2/3. It is the same as x to the 1/3 squared, or x squared to the 1/3. Why? Because of the power property. What's x squared cubed? Okay, so I'm going to start with this, get that, and then I'm going to say, okay, well, that's why we can write this. Anyways, what's important is, like, if I ask you what is negative 8 to the 2/3, well, instead of trying to like square then cube root, you could do whatever you want in whatever order. I could take negative 8 to the 1/3 and then square it. This is something I can do. It's like, what number cubed is negative 8? That's negative 2. Negative 2 squared is positive 4. Positive 4 times 3 is 12. 12 minus 9 is 3. Be the same thing here. Probably review that The square root of x cubed is the same as x cubed rooted, which is the same as x to the 3/2, which means it's the same as x to the 1/2 cubed. So if I ask you what's m of 9, I can just say that's the same as 9 to the 3/2, which is the same as 9 to the 1/2 cubed. 3 cubed is 27. 27 times -2 is -54. Minus 5 is -59. All right, solving equations. Here's W. When does W produce an output of 18? Undo what's being done. Get rid of the 9, get rid of the 3, then get rid of the 2/3, because x is being taken to the 2/3, then times 3 minus 9. So we're reverse engineering, reverse order of operations, this stuff. So we have, okay, add 9. Divide by 3. To solve, why do we square root? It's because a square root is a 1/2 power, and a power to a power you multiply. So what would I do here? I would take both sides to the reciprocal power 3/2. This is 9 to the 1/2 cubed. Square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. This would be a plus or minus because I'm using a square root to solve an equation. Okay. Here. Just going to go ahead and rewrite that. And now solve. Get rid of the 5. Get rid of the -2. To undo the 3/2, you could take both sides to the 2/3 power. 8 to the 2/3 is the same as 8 to the 1/3 squared. Don't need a plus or minus because you're not using a even powered root. Okay, the final one are an isolated like x plus or minus a value squared plus 4. It's a form of a quadratic. We'll be talking more about quadratics day 2, day 3. Just to familiarize with yourselves, these we can plug in and we can solve. Again, I'm going to probably have you guys try in class. See how you do. And based on how you do, you kind of know where you stand. You know how much you're going to have to work at it or not. It's like, oh, this homework's going to be a breeze. Or I'm going to really have to work on my fractions. I'm going to really have to work on my rational powers. I'm going to really have to work on whatever it is. Square rooting. We're going to prepare you for everything. The notes are based on the quizzes. The quizzes are the notes are based on the homework. The homework's based on the quizzes. The quizzes are based on the test. So we are going to get you ready for this difficulty. Now, this solving equation, let's see if we would do that. What up, Liggett? How you doing, man? What math class you in this year? Good for you, Liggett. Get after it. You're going to really like Mr. Connor. He's a musical man, just like you are. All right, bud. Good to see you. All right, we'll square roots both sides. Now, this is where we get this plus or minus. It's important to remember the plus or minus when you're using a square root. A positive or negative value squared can equal 25. You can either get positive 5 or negative 5 squared. But what we end up is like, oh, 9 minus 4 is 5. Like, we do need to add 4 to both sides, which is why we can have this, giving us two values, 4 plus 5, which is 9, 4 minus 5, which is negative 1. 9 plugged in here, minus 4 is 5, 5 squared, 25. Negative 1 plugged in there, negative 1 minus 4, negative 5 squared, positive 25. Okay? So that's it. These are the types of functions you need to review. Like linear functions, be comfortable with fractions. X to powers, whether, and what I'm going to review is x to a power, which is why if you have an x squared to the 1/2, you get x to the first. If you get an x cubed to the 1/3, you get an x to the first. This is why we square root. This is why we cube root. We'll review rationalizing. We will continue to review that. Here, I'm going to review fractions, multiplying fractions, adding fractions. We'll talk more about solving when we get here. This is all just planes. Some different types of problems just to finish off. We just have, 3 questions really in one. What's g of negative 3? What's g of 0? And what is x when g of x is 24? So I get 18 over negative 3 squared. I get 18 over 0, which cannot be done. We'll have to talk about that. And then we have 18 over x squared equals 24. I feel like we just did this problem. Yeah. I'd probably make it to an x to the negative first. Oh, it's a little bit different. Three-fourths, not 2/3. All right, this is a good one. We don't know what k is. I'm trying to find g of negative 2. If I plugged in negative 2 in for x, I got a problem. It's like, I don't know what k is. Looking for a numerical value. Okay. What we're going to have to do is use this information. When I plug in negative 12, my output should be 3. When I plug in negative 12, I get negative 10 plus k, which has to be 3. Okay, well then k has to be 13. Well, now I can figure out what g of negative 2 is. We get negative 5/3 plus 13. 13 turns into 39/3. (34/3). There's your answer. This is similar. If I plug in negative 3, I get A. It's not really similar. That's easy. This is 49. 7 squared is 49. 49 plus 4 is 53. This is one of those examples of like, guys, you have to be able to be adjustable, adaptable math students. We don't just do this in this class. We try to keep like consistent themes. One of the consistent themes of today is the idea that you understand that a power to a power you multiply, which is why for any kind of power, a reciprocal power undoes, whether it's a root, like a 1/2, which is a square root, a 1/3 is a cube root, or like a fractional power, 2/3. We're going to stick to common themes versus just do this when you see this. It's not going to work in this class. It doesn't work in AP Calculus either. Okay, and the last question. A rectangle has a length x minus 5 and a width 4. All right, don't know how you're listing those. This is Nicholas? Yo, how'd they let you out so early, bro?
Football, we were in the cafeteria.
You're early. What time's this class supposed to end? You solved this equation.
How you doing?
Good, man.
What equation?